Thank you, Araceli.
All right, recording started. All right, go ahead. Please show your work too. Yes, okay. Please. And show your work.
So, I guess I'll do the work first. That's fine.
So why are you using this, like, what is this equation, Antonio, for everyone watching?
Okay, so this is the amplitude, no, the period of sine normally, like the parent function is 2 pi over k.
So let me rephrase what you're trying to say. This formula, this is period equals 2 pi over k. This is the formula to determine the period, or in this case, to determine k, because I give you the period, and we know it's sine, and sine has a period of 2 pi. Now, if this problem, like on a test or a quiz, was talking about tangent or cotangent, instead of being 2 pi over k, it would be pi over k. So he plugged in the stuff, he solved for k, and we now know k is pi over 2.
This is probably wrong, but that's my final answer.
All right. So, Antonio, I want you to type this into GeoGebra and tell me if it graphs.
Oh, I'm forgetting x, aren't I?
There you go. Yep.
Let me try to move this over without making a big mess. It's going to make a mess regardless, but it's fine.
You actually don't want to move pi, or you can just write the x in right after it.
Okay. After the pi or after the whole entire fraction?
After the pi. Yeah, remember, pi over 2 is a coefficient, so you want to have the x
how did that?
Either to the right or in the numerator. Your test likes it in the numerator, so that is actually how I wrote the answer too, and nice job. So 2 is the amplitude, and then pi over 2 is k. So nicely done.
Thank you. Shout out to Chloe.
All right. Thanks, Chloe. So I had a question earlier before a lot of you showed up talking about, you know, I think it was Antonio says, well, do you mean 4 or do I mean 4 pi? And for this problem, I mean 4. So like problems we did yesterday, and then I think maybe in those modules, the learn and practice ones, you might have a mixture of the period being something with pi and without pi. But for this problem, I have it without pi. It makes a big difference. And we found that when Antonio solved for k, k actually included pi in it, and that's why we have it in this answer over here. So on your quiz, you're going to have ones like this. So pay attention when it talks about the period and the amplitude, and if the period contains pi or doesn't contain pi, because it's going to obviously change your work and your final answer. So yeah, just do the work and you'll be fine. All right. All right, so we are 3.03. This is day number 2, changes and shift. All right, we're being recorded as always. All right, so this should look somewhat familiar from last term when we talked about vertical and horizontal shifts. So remember the H and K. So this plus H or minus H, this is your vertical shift. And last term, what variable was this last term when we did problems like this involving shift? Anybody remember? It was K. Very good. Yeah. So it was H comma K. H was the vertical and K was the horizontal. And just like last term, when H is positive, it's a shift up. When H is negative, it's a shift down. When we have minus C, that's going to be a shift to the right. And when it's a plus C, it's a shift to the left. So the horizontal shift is still opposite from what we see it as. And I'm going to show you an example in GeoGebra. After I click a bunch of times just to share my browser. Okay. D'Antonio, do you all see this graph?
I do see it, and everybody else saying yes. Well, Emily said yes.
Okay, good. So again, just a quick refresher. We changed the x-axis to radians by clicking settings. Then we went to the x-axis. We selected distance. We selected pi over 2, and I personally like changing that to pi over 4, and then I hit enter to take effect. You can leave it as pi over 2. It doesn't matter. I just like seeing more tick marks every pi over 4. So, and then I went ahead. I put sliders in mine because it's easier for me to change this. So right now, my h and my c are both 0, and that's why it's y equals sine of x. So this is the parent function. Starting at 0, goes up to 1, goes back down. The midline crosses the x-axis at pi, and then it continues for the full rotation, stopping at 2 pi, and then we start over. So the period is 0 to 2 pi. All right, so let's go ahead and change the h value. So if h increases, all it does is shift my graph up. That kind of makes sense because that is a vertical shift. And then right over here, this shows my change in my formula, sine of x. X is in parentheses. It does matter. And then plus, in this case, 1.3 on the outside. And then if I bring h down so it's minus, well, it just shifts it down that many points. So vertical shift is super easy. You know, what you see is what you get, right? So one thing to note is the parent function. Your midline is at y equals 0. When you have a vertical shift like at 1, that midline changes from 0 to 1. So now the midline is at y equals 1. That's important to understand. You're going to have questions on your quiz in your modules talking about what is the equation of the horizontal line that matches the midline or something to that effect. Okay, let me go back and make it 0 again. All right, so I have x minus c. So let's make c shift to the right. So now it's x minus 2. And because it's x minus 2, remember, it's always opposite of what you see here. So because it's minus 2, it shifts it to the right. So this starting point here moves from 0 to 2. And then if c is negative, well, it just shifts it to the left. So now we have x plus 2.4. Because it's positive, it shifts it to the left. Remember, it's always opposite of the sign, just like last term. And then we can combine these shifts. So as you see, I shift to the right and I shift down. So pretty neat, right? Super neat. Let's see. All right, any questions so far? All right, easy stuff so far. Okay, this page is important. It's so important. All of you, see how I have like asterisks, 3 asterisks, horizontal shifts, asterisk, asterisk, asterisk. That must mean it's important. Super important. Everyone wake up. This is important. Horizontal shifts. So when you have y equals, in this case, sine, and you have k of x minus c. So when k is something other than 1, so like if there's like a 2 in front of that x, it affects your horizontal shifts in a way that you just can't pull it out directly. You actually have to take whatever number c happens to be and divide it by k. So, the easy situation is when, well, the number in front of x is just 1, right? Because then dividing by 1 is just itself. But that won't always happen. You're going to have like 2x, like y equals sine of 2x minus 5, for example. So this is important. The horizontal shift is determined by that number divided by the coefficient k. Super important.
Can you go back a slide really quick?
Sure. All right, hopefully that's crystal clear and not clear as mud, because that would be bad. All right, let's apply this. So now if you notice in all of my examples here, my k value is 1, my k value is 1, my k value is 1, and my k value is 1. So do I have to worry about taking my c value and dividing by k? Yeah, I sure don't. So these are the easy scenarios. So I want everyone, let's do number 1 together, and I'll give you like a minute and a half to do 2, 3, and 4. All right, number 1. So y equals cotangent of x minus 3. What is the horizontal? Let's do the easy one. What is the vertical shift?
Horizontal or vertical?
Vertical. I want the easy one first. What is the vertical shift?
Yeah, down.
I don't know. They're both kind of easy, right? It's all relative. Yeah, vertical shift is down 3. So you can say -3. I like using arrows. Maybe I'm just lazy. I don't know. Make sure I'm not using blue. All right, so vertical shift is down 3 units. All right, what is the horizontal shift?
A donut or 0.
So Antonio says 0. Emily says 0. Anybody else? Diana, do you want to defend why you think it's right 3?
Because wait, can you hear me? Yeah. Well, you said it's a down 3, and then you were saying that for the shifts that it's gonna be to the left if it's a plus, and then to the right if it's minus, and it says -3, so it'd be right 3.
I did, but let me ask you a question. Is this number inside the parentheses with this x?
Oh no, so it's C, it's not the K value.
Correct.
So would it be 1?
Is that x plus 1 or x minus 1 inside?
Oh no.
So what is the horizontal shift then? Well, don't say none. In math, I hate the word none. because it could be and especially NA. I guess you could say none. Yeah, I guess none works. I don't know about NA. Yeah, you could say 0 or none. There is no horizontal shift. And going back to kind of clarify, so yeah, remember the horizontal shift, it has to be within the parentheses. So for number 1, it was just X by itself. And if you wanted to rewrite that, we could rewrite it as Y equals cotangent of, if it helps, X minus 0 and then minus 3. And then that we can actually see that C is 0, and then obviously H is -3. So, but I wouldn't rewrite it. But if you want to, the first few, knock yourself out. All right, let's give you guys a minute and a half for the remaining 3 problems on this page. Minute and a half.
We just want transformations, right? We're not rewriting them.
What do you mean rewriting them?
Well, you rewrote it here to show. We don't need to do that.
Oh, no. Yeah, you don't need to.
All right, perfect.
I was just basically using that as a placeholder to show where C was. Yeah, we don't have to do that. Like, I don't need for you to like write +0 after this, for example. Unless you want to on your own paper. Is it safe to eat 50% off Valentine's Day chocolate? It is if you do 100% of the work to work off the sugar. But heck yeah, I don't know. Is there an expiration date on chocolate? How about you guys? I ignore that expiration date and I go by does it still taste good? Yeah, like I'll find chocolate that I've had probably for years and I was like, smell it, it smells all right. And then I do a little taste, like, it tastes fine. And then I just wait and see if I get sick. It's probably not a good strategy. I wouldn't say it's smart. It's probably a dumb strategy. There's expiration dates for a reason. At least that's what they say, right? Yeah, I think, doesn't sugar act as a preservative? Someone Google that for me. Does sugar act as a preservative? I could be wrong. I think salt acts as a preservative. Oh, does it really? Phew. Man. Yeah, I knew salt did. I was like 51% sure sugar did as well. Yeah, dairy products. All right. Anyway, let's get back to math. A minute and a half has been up. Volunteer to write the answer for number 2.
I can try if no one wants to. Okay,
all right, Caitlin, number 2. How about number 3? Dianica, number 3. How about number 4? 4. Okay, Emily, number 4. I feel like there's less volunteering in neuro. Is it because it's that terrible to write in? Okay, yeah, that's the impression I get. Yeah, the only reason why I'm actually able to write fine now is because right before class I switched over to my Mac and my touchscreen because it works fine in Mac OS. But in Windows, not so much. You want undo? What are you trying to undo? Oh, you got it? Okay. Oops. All right, let's take a look at these. Number 2, do we all agree with left pi over 6? I got yeses. Yes, sir. How about, yeah, wait. Oh, someone said wait. Hold up. Hang on. Remember, you can always type these in GeoGebra to confirm what you're thinking. On a test or a quiz, or even like your practice problems in your modules, I would recommend doing that. Which reminds me to remind you that those modules are required, and I check up on you guys every once in a while to see how much time you are spending in each module, because I can see down to the second each an individual module, the learn module, the practice module, of all the time that you spend in there. And if it shows that you spent a whopping 1 minute in like a practice or a learn module, I'm going to say there's no way you worked out any problem. You know, a lot of those modules, I expect probably around 15 minutes at the very least for most of them to work through them. All right, so left pi over 6. Yep, I agree with that one. How about number 3? All you agree with down 5 and to the right 7 pi over 6? Agree with that one. I do too. Yep, it is to the right 7 pi over 6 and down 5. Perfect. All right, so it looks like Emily fixed number 4. We're going up 1, and we are going to the left 2 pi over 3. Perfect. All right. Trying to trick you on this one by writing the h value in front versus after. Question for you guys. So like when I move my arrow, does it go behind the text?
It does.
Yeah. Well, that's weird. It does that for me too.
It's
Strange.
also like separating and like going all over the place.
Neuro is so good. These programmers should be so proud of what they created. They should be happy. There's a lot to improve, meaning they still have a job. All right, number 5 and 6. I'm a little bitter about Neuro. Can you tell? All right, so what is the horizontal and vertical shift? So number 5 and 6. All right, what's different about these two problems? What is the what's different? The coefficient.
Number in front of x.
Yeah, the k value. So is that going to change anything in our shifting? Or I guess when we pull out these shifts, is it going to change? Yes, it is going to change it somehow. So I would like all of you to do number 5. I will give you, I'll say 1 minute for the first one here. Oh, time is up. All right, volunteer to write the answer for the first one here. Volunteer to tell me the answer instead on mic, and I'll write it. If you want to show the work, you can, unless you're having problems writing in Numero, and you can tell me what to do, and I will do it. All right, Chloe, go ahead and do the first one. All right, Katie, you can do the second one as soon as we go through the first one. I want to give you guys time to do number 6. All right. Did everyone get pi over 4 to the right? All right. And how did we get pi over 4? What math did we do? C divided by k. Very good. So we took pi over 2 and we divided by the k value, which is 2. You do that math on your paper, and that's how you get pi over 4. And then up 2. Yep. Very good. All right. Let's give you a minute for number 6. All right, Katie, go for it. Pi over 2 to the left. I agree with that. And down 1. All right. Everyone agree with those? I think I do. Okay. All right, let's get to some harder problems. All right, graphing. All right, a lot of words on this page. What did I write? All right, so I think the best way to graph these transformations is choose a starting point. So a starting point would be your parent function. Generally speaking, it's either the origin or it's at y equals 1, 0, 1, depending if it's sine or cosine, or secant. Yep. So max and mins for sine, cosine, cosecant, secant, and then graphing the asymptotes for tangent and cotangent. I like doing the asymptotes with tangent and cotangent along with, if possible, the point where it crosses the x-axis. So for tangent, it crosses at, well, the origin, and you can graph those in GeoGebra to see those. And we'll do some. So going from those, and then once you have your shifting rules, you just shift the asymptotes and those points accordingly. All right, so whatever these are, one with cosine and one with secant. I went ahead and I kind of plotted the parent function already. So these points, I got some extra points in there. Let me delete those. So I just plotted some points of the parent functions of each. All right, so let's go ahead and figure out the shifting. Number 7, number 8. All right. All right. Let's figure out the shifting. I'm going to use green. All right. What is the horizontal shift? What's the horizontal shift? Right, pi over 4. I agree with that. Yep. So we're going to go right pi over 4. All right, and then what's the vertical shift? Down 1. Yep. All right, so all we got to do is take the parent function points. I actually plotted quite a bit of them, and we just move all of them accordingly. So let's start with the one at the origin. So down 1 and over pi over 4. Right. So it's going to be right here. So remember, pi over 4 is between 0 and pi over 2. All right. So that means we're going to move the one at the very end over. This will be about right there. Down 1 over a half. Here. All right. So it looks like this. Oops. Doesn't look like that. Let me start over. I started off being a disaster already. Okay. And that goes on forever, and then that just continues, right? So there is that segment of the graph. And we can always go into GeoGebra. We can type in and confirm that's what it is, and it should be correct. Everyone agree with that first graph? Okay, good. All right. Everyone go into GeoGebra and type in secant of x. Actually, you actually don't have to. I have it on this page here. I forgot I had it here. So this is the parent function, secant of x. So we have asymptotes at negative pi over 2, at pi over 2, and so forth. So every pi, we have an asymptote. So parent functions starts at 0, 1, and it opens up. And then these two, I guess you can call these, technically the pieces are parabolic shape, but they're not parabolas. This is at pi comma negative 1. That opens down. And this is at negative pi negative 1, this point here. So that is why I plotted just these points. So I plotted those points along with two asymptotes. We're going to use the shifting rules to move everything. All right. Let me give you... Actually, you guys shouldn't need any time. What is the vertical? Actually, let's do. What is the horizontal shift first? Horizontal shift. Left 3 pi over 4. I agree with that. And then what is the vertical shift? Up 2. Yep, I agree with that one too. Up 2. Okay, so let's do my asymptotes first. So we're going to shift the asymptotes left 3 pi over 2. All right, 3 pi over 2. So that's going to be 1, 2, 3. So it's going to be basically three tick marks, right? So 1, 2, 3. So my new one's going to be here. 1, 2, 3. And then my other one's going to be 1, 2, 3. All right. Do we agree on those, my two asymptotes? We're going to have to graph it on our quizzes. I don't think so. I think your quizzes make you just select the correct graph, if I remember correctly. Yeah, they make it super easy, I believe. All right, so then these other points, we have to shift them left 3 pi over 4 and then up 2. Let's start with this bottom left point here. So we're going to go left 3 pi over 2, then up 2, 1, 2. So it's going to be somewhere over here. It's off the graph. This one here, up 2, 1, 2, 3. It's going to be here. And then that last one, 1, 2, 3, and then up 2, 1, 2. Okay, so looking at the original, you're going to have this parabolic segment here. We're going to have the parabolic segment here. And then we're going to have another parabolic segment right here. Something like that. And you can go to GeoGebra, type it in, and confirm it, and even though it's an ugly graph, it is correct. So I would really recommend writing down the shifting rules and graphing them in GeoGebra and confirming what you know should happen. All right, let's try one more. I'm going to give you all, say, do we have time for 2 minutes? What time is it? Oh, I have plenty of time. Let's say 2 minutes to do this one, and then I'll take a volunteer to graph it in green for us. Try to do a rough sketch on your paper of this graph. Got about 30 seconds left. I wish Neuro allowed me to select everything that I drew on the screen and just move it all together. That would make this so much easier. In Blackboard, I could do that. If only. All right, volunteer to graph this for us. Write down the shifting first and then move everything and graph it. Anybody new? If not, I'll let Emily take it. Well, new meaning you haven't done an example for us today. Can you do control click or shift click to select multiple? Let me see if that works. I feel like I tried that and I don't. Yeah, that doesn't work. Which is no surprise. If we can't copy like an image from Google and paste it into Neuro, why would it be able to select everything and move it all together? Like why would we think that would work? Yeah, and also with Neuro, the more you write on the screen, the more it becomes laggy, which is not good for math. All right, looks like Emily, go for it. No one else wants to do this problem. Now, here's the question. Is it because you don't want to write in Neuro because it's just like a bad experience, or is it because you just don't know how to do the problem? The bad experience? Okay, that's fair enough. Yeah. All right, up 1. All right. Left. Pi over 2.
Wow, that is an awful pie.
No one's judging here.
I'm judging.
I'm gonna fix your pi, but you just keep going. I try to fix your pi. I just made it worse, so we're just gonna delete your stuff. It's like trying to fix a train wreck. It's not easy. There we go. Yeah, that looked like an N, but it's Neuro. I blame Neuro for that pi. Didn't you lag out yesterday too when you tried to write? Somebody lagged out.
Yeah, it was me.
Okay. It's my memory, my old age. Forget everything. Emily, how's that lag coming? There you go. We're seeing stuff. All right, good. So yeah, those asymptotes move over 1 tick mark, which is a pi over 2. Good. I like it. Oh, and if you're talking, we can't hear you.
That is because I am not talking.
Okay, well, that makes sense, actually.
That makes a lot of sense.
All right, so make sure you're following your shifting rules.
I'm trying.
You wrote down up 1.
It was up 1 because I thought it started. Oh wait, no, I'm dumb. Sorry.
There you go.
That's absolutely awful.
No, that's perfect. So I'm gonna do the same thing. I'm gonna draw the graph. Oops. Let me change the thickness. So here. And then
That was so smooth. I'm impressed.
it's because I'm using my Mac. If this was Windows, it'd be a disaster. And then there's asymptotes here too. All right. And you can go to GeoGebra, you can type this in, and you should get a better looking graph than what Emily and I attempted to graph, to confirm. But even though it's ugly, it is correct. So nice job. All right. Any questions on today's lesson on shifting? So the one takeaway is if your coefficient k is anything other than 1, do not forget to take your c value and divide it by k to find out the true horizontal shift. So that's a little caveat that commonly missed on quizzes and tests. People forget to do that little piece, and it costs them that part of the question. So be careful. And other than that, well, end of the lesson. And as always, I hope you learned something. And one last thing, people who are still submitting their part 2 of their exam, some people I make them submit it like 4 or 5 times. Like especially that number 2. And if you're getting like really annoyed with me that I am making you do this, it's because a lot of times in math, at least for me, getting to the answer is more important than the actual answer. Meaning, I need to know you know how to do it and you understand why you do it. And when you work out any math problem, you never run around. So for that number 2 people who have done it already, when you type in anything that involves like tangent, sine, whatever, and you hit enter, it gives you a decimal. No matter how long that decimal is, it is still a rounded value. And you don't want to do that. You want to keep it in that fraction form that had that tangent, because that is the exact form. It's reduced. It's a fraction. It's not a decimal. That is the exact answer. So once you have it, you get your parts of the problem set up, and and then once you type all of that in, that piece minus the other piece, and you hit enter, that final answer, that's what you round. So you want to save rounding to the very end. Never round your work. Now, there are some situations where you are forced to round your work based on limitations of your calculator or the problem itself. It's not possible to not round. In this class, we shouldn't get into situations like that. We might, I don't know. So keep that in mind. So, I'm really trying to teach you guys how to do this stuff and how to understand it. Getting the right answer is great and all, but you need to understand why. So I was really picky on that number 2 on this part 2 of the test. So don't get annoyed. I'm doing it for your own good. I'm not trying to be annoying or make you angry, because think about it. When you submit it, I have to regrade it. I'm making more work for myself. So I think it's worse for me. Anyway, thanks for coming, guys. I hope you learned something. See you tomorrow.